Hello students, and welcome to the lecture on programming language. After the lecture, we will be able to learn the following objectives: discuss types of programming languages, explain the history of C language, describe structure of C program, explain C variables, describe operators in C. Let's start with a brief introduction to programming language. As computers have developed over the past few decades, new generations of programming languages have also been developed to bridge the gap between programmers and machine code. An early solution to simplifying programming was the use of hexadecimal notation to represent machine instructions. Assembly language was the first programming language to address the problem of assigning meaningful names to computer instructions. This language used simple names like load, add, or store to represent machine instructions. A program written with these names was then converted into machine code using an assembler, a program that translated the names into the binary instructions understood by the computer. Languages such as Pascal, C, C++, Java, and Ada are all examples of third-generation languages that are widely used today. These languages are also known as high-level languages since they abstract away the details of machine code and help programmers to concentrate on problem solving. Now we will learn about the different types of programming languages. Web languages, used for creating and editing pages on the web, can do anything from putting plain text on a web page to accessing and retrieving data from a database. Varies greatly in terms of power and complexity. HTML, Hypertext Markup Language, the core language of the World Wide Web that is used to define the structure and layout of web pages by using various tags and attributes. HTML is used to specify the content that a web page will contain, not how the page functions. XML, Extensible Markup Language, a language developed by the W3C, which works like HTML, but unlike HTML, allows for custom tags that are defined by programmers. JavaScript, a language developed by Netscape, used to provide dynamic and interactive content on web pages. With JavaScript, it is possible to communicate with HTML, create animations, create calculators, validate forms, and more. VBScript, Visual Basic Scripting Edition, a language developed by Microsoft that works only in Microsoft's Internet Explorer web browser and web browsers based on the Internet Explorer engine, such as FlashPeak's Slim browser. VBScript can be used to print dates, make calculations, interact with the user, and more. PHP, Hypertext Preprocessor, a powerful language used for many tasks such as data encryption, database access, and form validation. PHP was originally created in 1994 by Rasmus Lerdorf. Java, a powerful and flexible language created by Sun Microsystems that can be used to create what runs inside web pages, as well as software applications. Things we can do with Java include interacting with the user, creating graphical programs, reading from files, and more. Software languages, used for creating executable programs, can create anything from simple console programs that print some text to the screen to entire operating systems. Varies greatly in terms of power and complexity. C, an advanced programming language used for software application development, originally developed by Dennis Ritchie at Bell Labs in the 1970s and designed to be a systems programming language. The Unix operating system is written in C. C++, descendant of the C language. The difference between the two languages is that C++ is object-oriented. C++ was developed by Bjorn Stroustrup at Bell Labs and is a very popular language for graphical applications. Visual Basic, a language developed by Microsoft based on the BASIC language. Visual Basic is used for creating Windows applications. The VB script language is based on Visual Basic. Here we will talk about different generations of languages. First generation languages, 1GL, represents the very early primitive computer languages that consisted entirely of ones and zeros, the actual language that the computer understands. Second generation languages, 2GL, represents a step up from the first generation languages, allows for the use of symbolic names instead of just numbers. Second generation languages are known as assembly languages. Code written in an assembly language is converted into machine language, 1GL. Third generation languages, 3GL. With the languages introduced by the third generation of computer programming, words and commands instead of just symbols and numbers were being used. Third generation languages are known as high-level languages and include C, C++, Java, and JavaScript, among others. Fourth generation languages, 4GL. The syntax used in 4GL is very close to human language, an improvement from the previous generation of languages. 4GL languages are typically used to access databases and include SQL and Cold Fusion, among others. Fifth generation languages, 5GL. Fifth generation languages are currently being used for neural networks. A neural network is a form of artificial intelligence that attempts to imitate how the human mind works. Procedure-oriented programming, a type of programming where a structured method of creating programs is used. With procedure-oriented programming, a problem is broken up into parts, and each part is then broken up into further parts. Some procedure-oriented languages are COBOL, Fortran, and C. Object-oriented programming, a type of programming where data types representing data structures are defined by the programmer, as well as their properties and the things that can be done with them. With object-oriented programming, programmers can also create relationships between data structures and create new data types based on existing ones by having one data type inherit characteristics from another one. Now we will talk about assembly-level language. An assembly language is a low-level programming language for microprocessors and other programmable devices. It's not just a single language, but rather a group of languages. Assembly language implements a symbolic representation of the machine code needed to program a given CPU architecture. Assembly languages are a more human-friendly form of machine language. Machine language commands are replaced by mnemonic commands on a one-to-one basis. The assembler program takes care of converting from the mnemonic to the corresponding machine language code. The programmer can also use symbolic addresses for data items. The assembler will assign machine addresses and ensure that distinct data items do not overlap in storage, a depressingly common occurrence in machine language programs. Look at the example to understand assembly language. High-level languages. High-level programming languages allow the specification of a problem solution in terms closer to those used by human beings. These languages were designed to make programming far easier, less error-prone, and to remove the programmer from having to know the details of the internal structure of a particular computer. These high-level languages were much closer to human language. Another advantage accrues from the use of high-level languages if the languages are standardized by some international body. Then each manufacturer produces a compiler to compile programs that conform to the standard into their own internal machine language. Then it should be easy to take a program which conforms to the standard and implement it on many different computers, merely by recompiling it on the appropriate computer. Many high-level languages have appeared since Fortran 2. Among the most widely used are shown here.
In the early days of computing, there was a language barrier between computers and humans because you had to use machine language if you wanted to talk to the computer, either in binary code or its exact English equivalent. This was very slow and laborious. Every time a generalist wanted to tell the computer to print something, or make a decision, or repeat an operation, he had to break every statement down into tiny electronic steps. The same for the mathematician who had to translate all his math symbols into long-winded computer talk. And even the businessman who just wanted to do payrolls and inventories and make out bills to his customers had to spell everything out in nitpicking machine language. But eventually, after a number of years, people began to realize that they were translating the same fundamental ideas into machine language over and over again. So they made lists of the instructions and symbols and procedures that each of them used most frequently, and they called these lists high-level languages. For example, BASIC for generalists, APL for mathematicians, and COBOL for businessmen. And then they prepared automatic dictionaries, which, just like English-French dictionaries, contained a list of all the vocabulary of the particular high-level language in one column with its machine language equivalent in a second column. Then, whenever someone wanted to use a key word or symbol or procedure in the high-level language, this dictionary would look it up, find out what it meant in machine language, and pass this on to the computer. These dictionaries, which automatically translated from a high-level program into a low-level machine language program, were in fact themselves programs, translator programs. And as soon as translator programs came into existence, people no longer had to speak machine language if they didn't want to. They could speak much more convenient languages such as BASIC or APL or COBOL or Fortran or Lisp or Pascal or Forth or any of hundreds of other specialized high-level languages that have developed over the years. The language barrier between computers and humans had broken down.
Let's now talk about the history of C language. The C programming language was devised in the early 1970s by Dennis M. Ritchie, an employee from Bell Labs, AT&T. In the 1960s, Ritchie worked with several other employees of Bell Labs on a project called Multics. The goal of the project was to develop an operating system for a large computer that could be used by 1,000 users. In 1969, AT&T, Bell Labs, withdrew from the project because the project could not produce an economically useful system. Besides assembler and Fortran, Unix also had an interpreter for the programming language, B. The language B was developed in 1969 to 1970 by Ken Thompson. In the early days, computer code was written in assembly code. To perform a specific task, one had to write many pages of code. A high-level language like B made it possible to write the same task in just a few lines of code. The programming language C was written down by Kernighan and Ritchie in a new classic book called The C Programming Language, First Edition. It was the standard on the language C. In 1983, a committee was formed by the American National Standards Institute, ANSI, to develop a modern definition for the programming language C, ANSI X3J11. In 1988, they delivered the final standard definition ANSI C. Characteristic of C. Some of C's characteristics that define the language are small size, extensive use of function calls, loose typing unlike Pascal, structured language, low-level programming readily available, pointer implementation, extensive use of pointers for memory, array, structures, and functions. It has high-level constructs. It can handle low-level activities. It produces efficient programs. It can be compiled on a variety of computers. The C character set. A character set defines the valid characters that can be used in source programs or interpreted when a program is running. The source character set is the set of characters available for the source text. The execution character set is the set of characters available when executing a program. The source character set does not necessarily match the execution character set. The ASCII character set has fewer than 255 characters, and these characters can be represented in 8 bits or less. However, in some extended character sets, so many characters exist that some characters' representation requires more than 8 bits. A special type was created to accommodate these larger characters, called the WCHAR1, or wide character type. The ASCII characters and their numeric values. For examples of characters are the 26 lowercase Roman characters, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and the 26 uppercase Roman characters, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. The 10 decimal digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we will talk about the structure of C program. Structure is the collection of variables of different types under a single name for better handling. For example, you want to store the information about a person, his or her name, citizenship, number, and salary. You can create this information separately, but a better approach would be a collection of this information under a single name, because all of this information is related to one person. Structure definition in C. Keyword struct is used for creating a structure. Syntax of structure. Look at the syntax shown on the screen. Structure variable declaration. When a structure is defined, it creates a user-defined type, but no storage is allocated. For the structure of person, the variable can be declared as shown on the screen. Accessing members of a structure. There are 2 types of operators used for accessing members of a structure. Member operator, structure pointer operator. Any member of a structure can be accessed as shown here. Let's look at how to write a C program to add 2 distances entered by the user. Measurement of distance should be in inch and feet. Keyword type def while using structure. Programmer generally uses type def while using structure in C language. Look at the example shown on the screen to understand this. Here, type def keyword is used in creating a type comp, which is of type as struct complex. Then, 2 structure variables C1 and C2 are created by this comp type. Structures within structures. Structures can be nested within other structures in C programming. Look at the example shown on the screen for reference. Now we will discuss the C variable. A variable is a named area of storage that can hold a single value. The C language demands that we declare the name of each variable that we are going to use and its type or class before we actually try to do anything with it. The programming language C has two main variable types: local variables, global variables. Local variables. Local variable scope is confined within the block or function where it's defined. Local variables must always be defined at the top of a block. When a local variable is defined, it is not initialized by the system. We must initialize it ourselves. Look at the example shown on the screen to understand it. Here, plus plus is called incremental operator, and it increases the value of any integer variable by 1. Thus, I++ is equivalent to I equals I plus 1. Global variables. Global variable is defined at the top of the program file, and it can be visible and modified by any function that may reference it. Global variables are initialized automatically by the system when we define them. If the same variable name is being used for global and local variable, then local variable takes preference in its scope. But it is not a good practice to use global variables and local variables with the same name. Look at the example shown to understand this. I in main function is global and will be incremented to 5. I in func is internal and will be incremented to 11. When control returns to main, the internal variable will die and any reference to I will be to the global. Let's now understand the operators in C. Operators are the symbol which operates on value or a variable. For example, plus is an operator to perform addition. C programming language has a wide range of operators to perform various operations. For better understanding of operators, these operators can be classified as arithmetic operators, increment and decrement operators, assignment operators, relational operators, logical operators, conditional operators, bitwise operators. Number 1, arithmetic operators. Plus is an operator, meaning addition or unary plus. It's also an operator, which is minus is also an operator, meaning is subtraction or unary minus. To make it clear, look at the example shown on the screen. Number 2, increment and decrement operators. In C, plus, plus, and minus are called increment and decrement operators, respectively. Both of these operators are unary operators, for example, used on single operand. Plus, plus adds 1 to operand, and minus subtracts 1 to operand, respectively. To be clear, look at the example shown on the screen. Assignment operators. The most common assignment operator is equals. This operator assigns the value in right side to the left side. To understand this, look at the example shown on the screen. Relational operator. Relational operators checks relationship between two operands. If the relation is true, it returns value 1, and if the relation is false, it returns value 0. To understand this, look at the table shown on the screen. Logical operators. Logical operators are used to combine expressions containing relation operators. In C, there are 3 logical operators. Look at the table shown on the screen to learn about the operators. Conditional operator. Conditional operator takes 3 operands and consists of 2 symbols, question mark and colon. Conditional operators are used for decision making in C. Look at the example shown on the screen. If C is greater than 0, value of C will be 10, but if C is less than 0, value of C will be minus 10. Bitwise operators. A bitwise operator works on each bit of data. Bitwise operators are used in bit-level programming. Look at the table shown on the screen to learn about the operators. Now in the end, let us summarize what we have learned in this lecture. Assembly language was the first programming language to address the problem of assigning meaningful names to computer instructions. This language used simple names like load, add, or store to represent machine instructions. The core language of the World Wide Web that is used to define the structure and layout of web pages by using various tags and attributes. PHP is a powerful language used for many tasks such as data encryption, database access, and form validation. An assembly language is a low-level programming language for microprocessors and other programmable devices. In C, plus and minus are called increment and decrement operators, respectively. Both of these operators are unary operators. They use a single operand. Plus adds 1 to the operand, and minus subtracts 1 to the operand, respectively. Relational operators checks relationships between 2 operands. If the relation is true, it returns value 1, and if the relation is false, it returns value 0.